experiments. She publishes 16 papers in IEE Explorer, Springer, Communication and Statistics. She awarded her paper was awarded at International Conference on Computational Intelligence and Computing Applications 2021, organized by Ryozoni Engineering College, Nagpur. We have pleasure to have you, ma'am. Over to you, Chaya, ma'am.
Okay, thank you, Lad Madam, for giving me this opportunity. Thank you, Radhika, for my introduction. And first of all, I must apologize as I have late because I have to handle also another same session for PhD like this for science faculty. So there is somewhat delay. But now, without taking much time, I will start directly my presentation. Okay. So the topic that I'm going to talk today is on testing of hypothesis, isn't it? I think all of you are already doing research. So, and I think you are well aware of the hypothesis testing since already it has I think more than 2 hours to your research. So, and I would like if this is an interactive session, isn't it? So, if possible, please give response to whatever the question or your queries are there, or there are the questions by me. Okay, now let's start. Is my presentation visible?
No, ma'am.
No, ma'am, not now.
Now is it visible?
No, ma'am.
All right. Anybody knows what is the hypothesis testing? Why we go for hypothesis testing? Yes. Is it visible now?
Yes, ma'am.
Okay. All right. So can anybody tell why we go for hypothesis testing? Because I think first of all, it is important to know why we are going for hypothesis testing. Okay. All right. Now let me tell you why we go for a testing of hypothesis. Because I think you have also some data, or you have collected the data, might be from questionnaires, or you have taken the secondary data, isn't it? But what we talk about in general is about the population from sample. It is not possible to collect the information about complete population, right? So what we do is, in generally, that we consider a small representative data of population that we sample, and from that sample we talk about the population, means whatever the characteristic is there under study about the sample, and then we talk about population, right? That's why when we are doing like this, it is very important to consider the variance, whatever is there in your data, right? And that's why we should go for testing of hypothesis, because from only sample if we claim, it is not going to be true everywhere, isn't it? That's why we should go for testing of hypothesis. Now, I will consider the things like that only, so that you should understand. I will not go in much statistical details. So there are two types of hypothesis. One is null hypothesis and another one is the alternate hypothesis, or it is also called as the research hypothesis. Okay. So null hypothesis means what? And it is very important that how you frame your hypothesis, because if you wrongly frame your null hypothesis, then the decision that we take will be exactly opposite what is there or what is true. And that's why the framing of correct hypothesis is very important. Okay. So I will take some examples also that how we should construct the hypothesis. Okay. So null hypothesis means what? It is a neutral statement or positive statement. That's why it is called as the null hypothesis. Means, see, whenever you are doing hypothesis testing, your interest is in showing that, suppose we are testing the one campaign is there and you want to see whether there is increase. Of course, what we want to see, increase in the sales of whatever the campaign is for, isn't it? Means what we want is increase. But our hypothesis in this case will be equal to, means the whatever the sales are there before taking the campaign and after campaign, they are not significantly different. This is what is your null hypothesis. That's why it is called as the null hypothesis, or neutrality, the positive statement that there is no significant difference. But actually we are interested in showing that there is difference. It has increased. That is what is the research hypothesis or the alternative hypothesis in which we are interested. Okay. So this is again important that our how we frame our hypothesis. Okay. So here are some examples of how to frame the hypothesis. The first one is, yes, there is no significant difference between growth rate of IT startups and traditional companies, because somebody wants to take. Nowadays, we can see that there is lot of importance and whatever the company, software companies, they are in boom. So somebody might want to see whether it is really true or not. In that case, he or she has to frame her hypothesis like there is no significant difference between growth rate of IT startups and traditional companies, right? Of course, alternative hypothesis will be opposite of that. That is, there is significant difference between growth rate of IT startups and traditional companies. Second hypothesis is Americans are not obese. Okay, against Americans are obese. Or Amitabh is favorite hero of 60% of people against Amitabh is favorite hero of less than 60% of people. Right? Like this, we can frame the hypothesis. Now, symbolically, if we want to represent this hypothesis, then it will be of the three types. As you can see here, the first hypothesis is mu is equal to mu 0. Right? Against this mu 0 is what? It is the population average. So mu is equal to mu 0 against mu greater than mu 0. Everywhere you will find that the null hypothesis is in the form of equal to. But alternate hypothesis is of three types. It can be greater than, less than, or not equal to type. Okay. So
Ma'am, are you share your next page? Hello, ma'am. Screen is not visible. Your PPT.
अरे 3-4 झाले स्लाइड तर I have already shared my screen. Okay, let me share it again.
Ma'am, your screen is visible, but slide can change. So first slide will be show there.
Now
Yes, ma'am.
it is there.
Yes, ma'am.
Now can you see that it is changing?
Yes, yes, ma'am.
Okay, okay, no problem. So, means only first slide you have seen.
Yes, ma'am. I put a message in the chat box.
Okay. All right. So let me open the chat box also. All right. So that I can see. No problem. And if there is any problem, please tell me. So we are here. So now you can see that there are three types of alternative hypothesis, and the null hypothesis is of the same type, that is in the form of equal to. These types of hypothesis will be there when we have only one sample. One sample means one group is there and we want to test some characteristic of that group. Then the hypothesis will be like this. Now, the hypothesis, null hypothesis is mu1 is equal to mu. Now, might you have understand that it is for two groups. When we want to compare some characteristic of two groups, our hypothesis will be like this. Null hypothesis always again in the form of mu1 is equal to mu2 is there. But the alternative hypothesis can be of type greater than equal to, less than equal to, and not equal to. Okay. Now, these are the, since we are again talking about some characteristics from sample, there will be errors and there are two types of errors, that is type 1 error and type 2 error. Type 1 error is rejecting H0 when H0 is true. It might happen because of course we are taking decision from the samples that actually it is true and still we are rejecting that hypothesis. It means we are saying that no, it is not true. Then it is called as the type 1 error. And it has very important role in testing of hypothesis because we took decision also in terms of this, how much error, type 1 error is allowed. On that, we are taking the decision. Then type 2 error is accepting H naught when it is false. Okay. This is called the confusion matrix where it is given what types of error occurs. All right. I will not go in much details. This is the acceptance region. Means if your test statistically is here, we will accept the hypothesis. And if it is lie in this shaded part, that is called, then we, it is called the critical region, then we reject the hypothesis. Okay, this is for one-sided test. That was for two-sided test. All right. Now let's start with the actual testing of hypothesis means actual test. Which tests are available? So first we will see one sample t-test. So from the name itself, it is clear that we have only one group, right? And we want to test the characteristic of that group only. So here the see, this test you can apply whenever your observation, you have some observations, data like measurements, okay? Then you should apply the one sample t-test, okay? So you can see on the screen that dependent variable should be measured at the interval or ratio scale, okay? Or in simple words, it should be quantitative, continuous, like study time, measured in hours, or intelligence, that is measured using IQ score, or exam performance, that are the marks, or weight, or sales, profit, loss, like this. When you have such characteristics, then you can use the one sample t-test. Of course, all the observations should be independent, right? Again, the requirement of applying the t-test is your data should be normal. There are several tests that are available for testing the normality of the data. Some of them I have listed here as Shapiro-Wilk test is there, Kolmogorov-Smiron test, or normal probability plot also can be plotted. I think as you are students of commerce and management, might you are using the SPSS software. So in SPSS, you will get it very easily. This thing of normality of the test. Okay. So the hypothesis, since it is for single mean or one sample t-test, the hypothesis will be simply mu is equal to mu 0 against h1 mu not equal to mu 0. Mu 0 means some specified number is there. For example, I will tell you. Suppose somebody wants to check whether the cell, okay, of a company, right, in particular season is suppose of 2 crores, right? Then mu will be on an average it is like 2 crores. Then the mu will be 2. That is 2 means this specified value, whatever the claim somebody wants to test, that will be taken as this mu 0. Okay, so that value is there. Now, if you are interested in, are you interested in formulas or software or what type do you expect? Means what is your requirement? According to that, I will go or proceed. Anyone want to comment? Okay, I don't find any answer from your side actually. Do you want to see the formula or software? You can talk through chat box also. That is not a problem. All right, as nobody is saying nothing, I will go on my own. All right. So this is the test statistic for testing the t-test. Y bar, that is the average of your sample. Mu 0, the specified value that we want to check. And S is the sample variance. Means whatever sample you have, its variance will be S. And N is the sample size that you have. Now it is important how we take the decision. So reject H naught means null hypothesis will be rejected if T observed, that is this calculated value is greater than the table value. Of course, at level of significance alpha. But nowadays, everyone uses the software for analysis, and in software, the p-value approach is given. Means p-value is given there, and we have to reject the null hypothesis if p-value is less than alpha, and accept the hypothesis, of course, null hypothesis, if p-value is greater than alpha. In this way, the decision is taken. Okay. So you can think about whatever your cases are there or topics are there, according to that, how you can take the decision. Okay, you can think like that. All right. So here I have taken one example that a public health official claims that the mean home water use is 350 gallons a day. To verify this claim, a study of randomly selected 20 homes was investigated with the result that the average daily water uses of these 20 homes were as follows. Means the data is collected for 20 homes, that how much water they spend daily, and now the claim is 350 gallons a day was used for the home usage. Okay. So like this. So in this case, our mu 0 will be 350 because we want to test whether the usage of the daily water is 350 or not. Gallons, of course, is not. Okay. So like this. So now you can think of your different research topics and how you can frame. So this was the composite hypothesis, simple hypothesis. Now for composite, we will have another example. The manufacturer of a new fiberglass tire claims that its average life will be at least 40,000 miles. Isn't it? This is the claim that it was at least means minimum 40,000 miles. We are interested in seeing this at least it is 40,000 miles or not. But when we consider the hypothesis, that will be our research hypothesis, okay? And to verify this claim, a sample of 12 tires is tested with their lifetimes. So these are the in thousand of miles it is given, okay? So like this, we can also test for the one tail hypothesis, that is mu, was it less than 40,000 or not, okay? Now let's take another and simple example. A random sample of size 16 was taken from a population and the IQ scores were measured. The IQ score measured are as given below. One, this all figures are for the whatever the sample of 16 people is taken, it is their IQ is measured and it was given here. It is claimed that the IQ score of the population under study is 110. Okay, this now our mu zero will be 110. We want to test here whether the average IQ is 110 or not. Okay, so our hypothesis H naught will be constructed as, I have not mentioned that here, no problem. But we want to test that. So the null hypothesis will be the average IQ of the people is 116, or in symbolically you can write down mu is equal to 116 that you want to test. So here this is the output from SPSS I have done. In SPSS, if you do how to test normality, then there is option. You will find that Kolmogorov, Miron and Shapiro will test is there. Here it is for IQ. Now, in this is the value of test statistic. These are the degrees of freedom, and here is the significance value. In SPSS software, this significance value means nothing but it is the p value. Okay, now since this p value is 0.2, which is greater than 0.05, so we have to sorry. This is not about t-test, but it is about checking of normality. Again, it is greater than 0.05, so we can say that the data is normal. And same is the case from Shapiro-Wilks test also. This is significant, that is the p value, that is 0.977, and that's why we have to accept the null hypothesis that data is normal and we can use the t-test. If the data is not normal, then we have some different options for testing. Okay, so this is how the calculation is done, but I don't think you are interested in calculating all of these things. Or if you want, I can go fast here quickly. I will tell you. So this is what are the observations are there, and here we have the average of all the observations, that is 117. This is how the sample variance is computed, 1 upon n minus 1. Since 16 observations are there, it is 15. Then summation yi, that is every observation, minus mean, that is 117. We have to square it. For example, if the value of yi is 120, then 120 minus 117, that is the average, its square means it will become 120 minus 117, that is 3, its square is 9, plus second value minus mean, its square. Like that we have to compute for all the observations and you will get the value of s square, that is 74.133. Then find out the square root of the sample. Okay, then the test statistic. So this is the value of the test statistic that we have. Now this is the table, T table. On internet, if you just Google for T table, you will get this type of tables. So here are the different values of the alpha values are given for you for one tail test, for two tail test. Okay, so if you want your hypothesis is one tail, alternative hypothesis, then you should go and see the value of alpha here in this first or second row. Then if your alternate hypothesis is not equal to type, is also it is called as two tail test, then you have to go for this third row here, right? And here in the first column, the degrees of freedom are given. Now, since we have 16 observations, the degrees of freedom will be 15 here. And suppose our test is two tail test and 0.05, we have to see, then see this is the column of 0.05 for two tail test, and this is the degrees of freedom that are 15. So we will take this value, that is 2.131. In this way, we can consider the table value, okay, for comparison. And the test is, decision is taken like this. If T calculated is, means test statistic value is greater than Tn minus 1. See here, I have already mentioned this. T15 at 0.025 level of significance, it is 2.131. Okay, and this is the calculated value. Now this calculated value is greater than this tabulated value, and so we have to reject H0. Means the average IQ is not, sorry, we are testing 110. So the average IQ is not 110. That is how we take the decision. Okay, all right. Do you use the Excel? If you want, I can show you in Excel how we can do the testing of hypothesis in Excel. So if you are interested, please tell me. You can unmute yourself and tell me, or you can write down in chat box also, no problem. Yes, somebody has said yes. That yes, you want to see how it works in Excel. So let me share Excel first. Are you able to see Excel also on screen?
Yes.
Yes, ma'am.
Yeah, please respond so that I can understand that you are there. All right, so I have copied that whatever the sample is there. This is the sample, right? Now I will write, as this is comma separated value, I will give my observations here, observations, okay? So the observations are 105, 116, 112, 134, 108, then 118, 120, 110, 123, 112, 103, 122, 125, again 120, 124, and 130. Now if you see just these values, we cannot say what is there and whether it is really 110 or not, right? So just we have to input the values in one column. Then, oh, I have to tell you first of all, in which package you will get all this hypothesis of testing. Excel sheet is visible, na?
Yes.
Yes, ma'am.
Fine. Then go to file menu. In that you will have Excel options. So go to this Excel options. In that we have add-ins. So click on add-ins. Then you have here the first option, that is analysis toolpath. Select that and just click on go. I have already, it is installed in mine, and then again you have to click on OK. You have another options also if you are using Excel. Nowadays, many things can be done in Excel also. So now I have the toolpack of data analysis. So it is in the tab of data. So go on the tab of data. In that you can see here that is the option data analysis. So click on that data analysis. In that many statistical tests are there and several descriptive statistics also you can find from here. Isn't it? Like this, ANOVAs are there, correlation is there, covariance, descriptive statistics, many more things are there. F test is there, histogram is there, moving averages are there, random numbers are there. Okay, regression is also there, sampling is there, but we are interested in testing of hypothesis. But now you can see that there is no option for one sample t-test, isn't it? It is for paired and two sample test. But we want to do now for one sample t-test. So we will use two sample t-test for testing one sample. And for that, we have to give one more observation. I will give it as group 2 and some zeros I will just enter because we don't have a second. We have to use single sample t-test. So let's give another one as 0. And now again I will follow the same path. Go to data, then data analysis. And now I will use the two sample t-test. Okay. And then click on OK. Now new window will get open in front of you. Now we have to give the variable 1 range. Means whatever is your group 1 range that we have to select. So this is my variable 1 group range I have selected. Then variable 2 range I have to select in another box. So I will select this another variable. Then hypothesized mean difference. This means whatever the difference or mu is equal to mu 0, that value we have to give here. We want to test whether the average IQ is 110. So I have here input 110, right? Now, since I have selected in data the titles also, I will click on labels. Okay. Now we have to give the output range, means where you want the output. Okay. So click on output range and then select some cell from here, wherever you want your output. And there is another option also, that is the new worksheet. If you want your output in the new worksheet, you can go for this second option. Okay. All right. Okay. I will also go for second one. In that case, you don't have to give the range. Okay. And then click on OK. Now a new sheet gets open and I have the output of my test here. So we can see that here in the first is mean average 117. Already you can see from the calculation part that the mean is 117, right? Then variance is 74.133. If you calculate it manually, you will get the same value. Then number of observations are 3. Now group 2 is the only dummy variable we have considered. So if you want, you can just delete that variable. We don't want this. We have single sample. Then hypothesized mean difference, that is 110, degrees of freedom are 15. This is the test statistic, that is 3.25. Now this is important value. P, probability of P less than equal to T for 1 tail. Means if your alternative hypothesis is 1 tail, then you have to consider this is P value. Okay. Though directly it is not given, this is the P value. And this is the table value. Okay. Now again you have the same, that is probability of T less than equal to T, but now for 2 tail. Means if your alternative hypothesis is 2 tail or of type not equal to, you have to use this P value, that is 0.005, right? Now this T critical value means table value it is there. Already I have shown you from the table that it is 2.13, isn't it? it is also same here. It will give it. That is the table value 2.13 for two-tail hypothesis. Now we will take the decision from this p value and it is 0.005. Means this value is less than your level of significance. We have considered level of significance as alpha, that is 0.05. So this value is less than 0.05. So again you have to reject your null hypothesis. Means the average IQ is not the 110 or 110. And if you want to give it scientifically or that API style, then there is not it is interpreted like there is no sufficient evidence to accept that the average IQ is 110. Like this also you can interpret the results, right? So this is for one sample t-test. Now let's go for the another one. Again, PPT is visible.
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Okay, thank you. Now let's consider the another example or another test that is of the two sample t-test, or it is also called as independent sample t-test. Now from the name itself it is clear that we have two independent groups, right? If we want to consider the same example that is of IQs, then here it can be extended as there are two groups of male and female, and we want to check whether the average IQ of male and female, is there any significant difference, right? Like such examples. Or suppose two companies, somebody has given the campaigns to two different companies and wants to check whether the both companies, the sales after the campaign of both companies, is it same or not? Like this, if somebody wants to check, then one can use this independent sample t-test, right? Or many cases, whenever you have two groups, when you want to check the whether the averages of two groups is same or not, you can use the independent sample t-test. Again, see, for using this test, you have to select a sample. Means if campaign is there, then you may take the daily data or weekly data or monthly data depending on the situation, right? Like this for some 10 days, 15 days, or means data of 15 time periods, like this 15, 20, 25, whatever is there, you can consider that and then you have to apply this test. Okay. All right. Then again, symbolically, the hypothesis will be given as this. Null hypothesis is mu1 is equal to mu2 against the alternative hypothesis is mu1 not equal to mu. Okay. Assumptions. Again, here also we need the normal distribution. Both the whatever the groups are there, they should be normally distributed. Observation should be independent, right? Then a homogeneity of variances means variance also. I think already you have one lecture on this, isn't it? Centers of measures of central tendency and dispersion. So might you may be knowing what is variances. Then homogeneity of variances is also one of the options. If not, then there are again different options for testing. Okay. All right. Then here test statistic is given like this: y1 bar minus y2 bar. Of course, y1 bar is the mean of first group, y2 bar is the mean of second group, average of first and second group. Then this is the pooled variance. When we have two independent groups, we have to find out the pooled variance, right? Already have explained how you will find out sample variance for one sample case. It is the same sample for first group into n minus 1. That is number of observations from first group minus 1. Then number of observations from second group minus 1 and sample variance, right? And completely divided by whatever the total sample is there minus 2. Again, the decision you will take as reject H naught if mod T is greater than T N1 plus N2 minus 2 at level of significance alpha. This criteria is always same when you do it manually. Reject H naught if your calculated value is greater than table value. Otherwise, you have to accept your null hypothesis. And p-value approach also will be same, reject H naught if p-value is less than alpha. Otherwise, accept H naught. Like this you have. Now here I have taken one example for independent sample t-test so that your ideas will be clear in which situations we can use the independent sample t-test. Okay. I will see if another example is there. Okay. So we have taken 22 volunteers at a cold research institute caught a cold after having been exposed to various cold viruses. A random selection of 10 of these volunteers was given tablets containing 1 gram of vitamin C. These tablets were taken 4 times a day. The control group consisting of the other 12 volunteers was given placebo. Placebo means what? It was not actually the medicine, but only given in the name of medicine. It can be mineral water or just like something like that, which actually have no effect like medicines. Okay, that is called as the placebo. So placebo tablets that look and tasted exactly the same as vitamin C tablets. This was continued for each volunteer until a doctor who did not know if the volunteer was receiving the vitamin C or the placebo tablets decided that the volunteer was no longer suffering from the cold. The length of time the cold lasted was then recorded. At the end of this experiment, the following data resulted. Means if in short, we want to see these are the observations when placebo, that is not actually tablet is given to some patient, and these are actually the patient who has given the tablet and what is the their what is the effect of their tablets and placebos that were observed, and we want to see whether both have the same effect or not. So in like this also examples, the independent sample t-test can be used. Again, a very simple example is I have considered 2 independent group of children were tested to find how many digits they could repeat from memory after hearing them. The results are as given below. Right? We have 2 independent groups. Nowadays, it is time for elections. Okay, so everybody claims that our government is better. So suppose 2 different states are there and we want to see how are the whatever GDP role of that state. Like this also can be compared from different commodities, isn't it? Or if you have the data of growth rates for some 10-15 years, and you can check from this government type and that government type what are the differences. That also can be tested using this independent sample t-test. Now I think there is no need to explain this calculation. Was it needed? Is it needed?
Yes, ma'am.
Okay, right. Then I will explain this. If you are interested, then no problem. Okay. So this is the average of first group, right? Means this group A. If you find average of this, you and average of this group is y1 bar. Average of this group will be y2 bar. Then sample variance, that is 1 upon n minus 1 summation. This observation minus the average of this group, right? Like for every observation, if we do, then it will be S1 square, and for this group, it will be S2 square. Okay, see here, I have already calculated and given here. S1 square is 1 upon n minus 1 summation yi minus y bar square, and that is 1.73. Similarly, you can find out the sample variance for second group, and it is 2, right? Average of first sample is 6.2. Again, in independent sample test, you can have different number of observations. That is not a problem in independent sample t-test. Okay. So in first group, we have 10 observations. So the average is calculated as total of all these observations divided by 10, and here are only 9 observations. So average of all, addition of all these observations divided by 9. That will be the average of second group, that is 7.33. Right? Then here 1 upon n1 minus 1, n1 is 10, so 9. Then take the first observation from here, that is 8 minus mean, that is 6.2, its square, plus second observation, suppose it is 5, then 5 minus 6.2 its square, plus whatever the third observation is there, minus this mean 6.2 its square, plus. For like this, you have to do this for all the observations, and then divided by total number of observations minus 1, that is 9. So in this way, if we compute this, it is 1.733. And for second group, it is computed like same way for the second group. Now, instead of y bar, you have to use this value, that is 7.33 here. Okay. And you will get this value finally, that is 2. Now, you have to find out the pooled variance as n1 minus 1. Means again 10 minus 1, that is 9. Into S1 square means this value, that is 1.733, plus N2 minus 1, that is in second group 9 observations are there. So 9 minus 1, that is 8, into S2 square is 2. So into 2 and divided by N1 is 10 plus 9, that is 19 minus 2, that is 17. So here we have 17, right? Like this, you have to find out this value. This is 1.8588. Then the test statistic, this test statistic is there. We have to put the values for this specific example. So it is 6.2 minus 7.33 divided by 1.85 into 1 upon n1, that is sample size for group 1, plus 1 upon sample size for group 2. So in this way, you will get here the value, that is minus 1.80. Yes, t value can be negative also. Okay, so no problem if we get here the negative value. Then the decision criteria, it is reject H naught if mod T. Mod means although it is negative, we will consider the positive value. Means it is minus 1.8, but here since mod is there, we will consider it as plus 1.8. So 1.8, if it is greater than the table value, then at alpha percent level of significance, then we have to reject. Here, this test statistic value, this is 1.8, okay, and table value, from that table again you have to see what will be the value for degrees of freedom are 17, isn't it? So in that first column, 17 number, see where is the figure 70, and in first row you have to see 0.05 for 210. Whatever the intersection of both values is there, you will get that is 2.110. And you have to, now since 1.8 is less than 2.10, so what is the decision? Yes, what is the decision? We have to accept now H naught, because this calculated value 1.8 is less than 2.10. So we have to accept H naught at 5% level of significance. And you will finally give the interpretation as there is sufficient statistical evidence to infer that the null hypothesis is true. Null hypothesis is true means what? The difference between mean scores of the two groups A and B is not significant, right? Because H0 is, there is no significant difference. But now we have rejected that. Means there is significant difference in, sorry, we have accepted H0, means yes, there is no significant difference between the average scores of both the groups. Okay, like this you can write down your interpretations. This is again the output from SPSS. In SPSS there are many things which are there by default. You will find that it is actually a very good software where so many things you can find. Okay. So, what I have taken one assumption as testing equal homogeneity of variances. So, in SPSS software, there is no need to select that option. You will by default get this, that it will test whether the both samples have equal variances or not. For this equality of variances, you will find here significance means first p-value. It is 0.840, again greater than 0.05. That is the level of significance. And hence you can say that, yes, there is not significant difference in the variances of both the groups. Okay. So both equal variance assumption is followed here, or it is there, right? Then here you will find the second significant value, and now this is for t-test. You can see here that this is the t-test for equality of means. Here this is the 11th test for equality of variances. Ultimately, our main goal is to find out this value, or we will interpret from this value. This is for the assumption or the requirement of the t-test. This part is for that, and this is your actual test figures. Okay. So from here to tell test again it is 0.08. So we have to accept H0. See, if you are observing, then whatever if you are taking the decision from t tables or manually or from p value, you are getting the same result. Okay, that is always there. By any method, if you will do it, finally you will get the same result, right? And here also, since this value is greater than 0.05, we have to accept H0. Okay, means there is no significant difference between both scores. Is it clear? Is it clear or not?
Yes, ma'am.
Right. Now I would like to show you how you will do this independent sample t-test in Excel. Okay, so let me copy this table. Copy this. So I will copy this. This was our previous observations. Now new observation, I will paste it here, right? So this is my new table of both groups, group A and group B. All right, now again we have to follow the same path. Go to data tab, then go to data analysis. In that, we have to select now t-test for two sample assuming equal variances. Already I have shown you output of SPSS that the homogeneity of variances is accepted, means our data has equal variances. So now we have to select this option and then click on OK. Again, you have to give the variable 1 range. So select variable 1 range from here, right? Then again go back, variable 2 range we have to select. So I have selected, this is the range of variable 2. Okay. Now hypothesized mean difference. Now our H0 is both are having the same scores, right? So their difference is 0. So I have to now consider here 0. Previously we have considered it as 110 because at that time we have to check whether the average IQ is 110. That's why 110 here. Now this is two sample t-test. So you have to consider the difference as 0, right? And then again I have included the labels. So just check on labels. And then again where you want the output. Now suppose I will consider my output here only. So I have to select my output suppose here. Then select where you want the output and then click on OK. Now since I have click on the same sheet, I have my output here. Now you can check the output. See this. The average is 6.2 for first group. Average of second group is 7.33. Variance of first group is 1.733. Variance of second group is 2. If you remember the computed value, then also it is same. Excel sheet is visible, na?
Yes, ma'am.
Yes, ma'am.
Right. Now the number of observations from first group are 10 and from second group these are 9. Pooled variance, that is SP square, we have computed manually also. It is 1.85. This means hypothesized mean we have given it as 0. Degrees of freedom n1 plus n2 minus 2, that is 17. Then test statistic we also have got the same, that is minus 1.80. Then this is the p-value for one tail test, it is 0.04. Then this is the table value for one tail test. Then this is the p-value for two tail test. We will take decision from this value. This is 0.0088. Again, this value is less than 0.08, right? And this is the table value. Now again, since this value is 0.08 greater than 0.05, so we have to accept H0, that there is a not significant difference in the averages of both the groups. So like this, you can compute this in Excel also. So I think it is quite easy to find this in Excel also. Now let's go to our third test, that is the dependent sample t-test. Okay, this is independent, where your group should be independent. Now dependent sample or paired t-test. From the name itself, it is clear that your samples should be dependent. Samples are or groups are dependent. Mind this, groups are independent, but observation within themselves means if you consider first observation and second, they are independent. But if you consider the observations from different groups, they are dependent. Like this, it is a dependent sample or paired t-test. Okay. Again, another requirement in previous independent sample t-test, you can have different number of observation in both groups. But here, independent sample t-test, see, these are the examples of the type like what is the cell before campaign and after campaign, right? Since I don't know much examples from your faculty, I have to stick up with the same example, okay? But I think you can imagine whatever, how you can apply this in your research or in your faculty stream like that, okay? So here dependent means whatever the cells are there before campaign and after campaign. If you want to see whatever is the impact of that campaign on cells, then you can suppose at 15 places that campaign was taken. Then you will collect the data from all 15 places and we find collectively whether that campaign is successful or not. So like this, when the situations are there, we can use this dependent sample or paired t-test. Okay. So, and that's why this number should be same. N1 and N2 must be same. Got it now? Because we want to see the cell at that place before campaign and after campaign. And that's why it depends. Because it is of the same place. That's why it is dependent, right? And so of the same place or location, what is the cell before campaign and after campaign. And that's why our N1 and N2 is same. That is the number of observations from group 1 and group 2 that are must be same. Okay. Of course, the assumption of normality is always there. When you have to use t-test, normality is must. Now, if you observe that previously also we have the same hypothesis, that is mu1 is equal to, if we write symbolically, then it is mu1 is equal to mu2 against the same, that is mu1 not equal to mu2. There also if we write symbolically, it will be the same statement. But you should understand that the situations are very different. You should not use this test statistic while doing for independent sample test or vice versa also. If you have independent sample, you should not go for paired t-test, right? So it is very important that in which situation you will use which test. That you should understand or identify. That is very important. Otherwise, your confusion, whatever you are doing, that may go in wrong direction. All right. So this we have. Now, since both the observations are related, then now we will define here the third variable, that is di, as the new variable. Suppose xi is the variable of your group 1, that is the cells before campaign, and yi cells before campaign of the same location. Okay, I is here. Remember, or you can see that. Means of the same location, you are considering cells before campaign and after campaign. Like that, your new variable is defined here as di. Then the test statistic in this case is d bar, means just now we have defined the variable di. This d bar is the average of all that di's, right? Then this mu d is the difference of the population. Of course, we will take 0 because generally we consider the null hypothesis as there is no difference in the cells before and after campaign. Okay, that will be your H naught. And that's why no difference is there. So we will consider this mu d as 0. Okay. Then SD is the standard deviation, but for the newly defined variable, that is DIs. Calculation you will do in the same manner. Formula is same, but for now it is for the new variables, that is DIs. Okay. Same way, d bar also you have to find out for the newly defined variable di. Right? Then the number all right. Some I think internet issue was there. Am I audible now?
Yes, ma'am.
And is the screen visible?
No.
No. Okay, I will share it with you.
No, ma'am.
Okay, I will share the screen. Is it visible?
Yes,
Yes, ma'am.
Yes, ma'am.
Okay,
Yes, ma'am.
Now visible, ma'am.
right. Thank you. Okay. Yes, so let's see the example. A certain training was given to 8 workers to increase the productivity, right? in your case, maybe to increase the sales, right? The productivity was recorded before and after training for these workers. The production in thousands is given in the following table, right? So here is the table where the actual observations are given. Now you can observe that here the number of observations are same, right? Because it is of the production of the same workers on same machines before and after training. If you just observe, we cannot say what is the impact, isn't it? So now again I will copy this. No, all right. I will show you afterwards in Excel. Now let's see here how we will compute it manually. So again, hypothesis is mu d is equal to 0 means there is no impact of training. Okay, or there is no significant difference in the production before and after training. That is how we will frame our H0. Of course, alternative hypothesis will be exactly opposite of that. So there is significant difference in the production before and after training. Like this, you can frame your alternate hypothesis. Now, the average, right, d bar will be calculated as summation of di's, means xi minus yi. For this example, your d1 will be 23 minus 27, that is minus 4. Then next d2 will be 28 minus 37, that is minus 9. Like this, you can find out all the differences. Okay. This. Then di, summation di, that is the differences xi minus yi for all the observations divided by n the number of observations. I think that is 10 here. So it is minus 2.875. Yes, it can be negative. No problem is there. Okay. But this sample variance, it is never negative. If you are getting negative value of this, means you are doing something wrong. Okay. You have to check other, again, your calculations and what you have considered, whether it is correct or not. Then the sample variance is computed as square root of, yes. In previous slides or test, we have computed S square. Now here I have considered SD, that is the standard deviation, which is the positive square root of whatever sample variance is there. Okay, so do not get confused. It is the same formula. 1 upon n minus 1 summation di square minus n times d bar square. Actually, this is also the same formula for sample variance. Di minus d bar whole square, like this. Okay, or this is the simplified form of that formula, so you can use this also. There is no problem, both will give you the same answers. And this is square root of 14.9821. Okay, so this is 3.87067. Then this is the value of test statistic. D bar means this average value minus 2.875 minus mu d is 0. So you have to put this at 0. Then SD means this standard deviation, that is 3.87 divided by square root of n, means the total number of observation and square root of that value. Okay. So it is minus 2.1008. Again, it is a t table or t-test, so you can get the negative values. There is absolutely no problem with negative values for t-test. Okay. Then again the decision criteria, you have to reject H0 if mod t is greater than t at n minus 1 degrees of freedom. Means in that table, if you want to see, again you have to check at n minus 1 degrees of freedom at alpha % level of significance. Okay, generally we consider 0.05. But if somebody wants, can check that, change that value also. Some people take 10% also, means more error is allowed, like that. So this value comes from the table, that is 2.365, and you have to reject it mod t is greater than tn minus 1. Now you remember this value, it is 2.365. This is the table value. If we check the calculated value, it is 0.2.1008. And now see the decision criteria, it is mod T. Mod T means what? We will not consider negative. So we will consider only 2.1008, that is positive value. This positive value, if it is greater than T at n minus 1, means this table value, that is 2.365, then we have to reject H0. But in our case, that value is, I think, 2.1. So 2.1 is less than this table value. So it is not fit in this criteria. It is against this criteria, means this value. It is satisfying this criteria, that is mod T is less than Tn minus 1. And so we have to accept H0, right? At 5% level of significance. And if you want to interpret it in a scientific language, then you can interpret it as there is sufficient statistical evidence to infer that the null hypothesis is true. We are accepting H0. Yes, the null hypothesis is true. That is the difference between production before and after training is not significant. Means it is not significant. Significantly different. It is approximately same. That is how you can interpret your result, right? So this is dependent sample t-test. Again, this is output from the SPSS. So here one more value you will see, that is correlation. This value we want we want it a significant correlation. There should be significant correlation between the value, because these are these observations taken on the same samples or the same individuals. So there is obviously there will be correlation in this, and yes, this is significant. Whenever in SPSS you will find significant, it is the p-value. But for what this p-value is, that you should understand. This is for correlations. This is p-value is for correlation. Means there is significant correlation. Accepted. Yes, there is correlation between the samples. Okay. Now, this is the test that we have, and this is the test statistic, isn't it? That is minus 2.101 degrees of freedom, and this p-value, this is the p-value for the t-test actually, it is 0.07. Means we have to accept it not. See, if we take manually using tables, then also we have accepted hypothesis. If you are doing it in SPSS, then also your test is having the same result, that you have to accept your null hypothesis. And now let's see in Excel also, because why I go for Excel, because it is freely available to anyone who have the computer and can do it very easily. So I have selected this Excel for you. That is what is the reason. Now again we have to copy this. So I will copy again this data. And we have to paste it in here again in Excel sheet. I will take a new sheet now. Okay. So here, what we have. Right. Now again, follow the same path. That is, Excel sheet is visible.
Yes.
Yes, ma'am.
Okay, fine. So go to data tab, then go to data analysis. Then now we have to select for pair t-test. Remember this also, that every time we have selected different tests. All are t-tests, all three are the t-tests, but every time we are selecting different. So this is t-test for paired or two sample means. And then click on OK. Again, we have to give the range of variable 1. My variable 1 is after training. Then variable 2, that is before training. Okay. Mean difference. Again, we want here 0 mean difference. We are assuming that both are having the same productivity is same before and after training. So we have to consider here as 0. Then If you want a new worksheet, you have to select, by default, you will get this. If you want to give on the same sheet, then you have to give the output range where you want your output. So suppose I want my output here, then I have to select just one cell will be sufficient. It is not selected, otherwise it will be there, what its location or position of that cell. Now it is here. And then click on, oh, some problem is there, I think. See, only one observation is selected here. So I will, no, I will select again this. Now it is okay. B column and cell 2 to 10. I have selected now. We can see that here. Okay, so now I think everything is fine. So click on OK. And here we have the output for the pair teams. Now we can see that first is the mean for after training. What is the mean of this production value? That is 32.5. Before training, it was 29.625. Variance of after training observations is 26.25, and before training, it was 14.55. Both are having the same number of observations, and that are 8. Okay. Then here also in SPSS also we have got this Pearson's correlation value, isn't it? And here also we have the same correlation, that is 0.66. In independent sample t-test, that at that time it was, this value was not there because it don't have any role in the independent sample t-test. But here, yes, there is some correlation. Then mean difference 0, degrees of freedom are 7, that is 8 minus 1. Then this is the test statistic, that is 2.10. This is the p-value for one tail test. This is the critical region with stable value for one tail, and this is stable value for two tail. Here you can find it very clearly for what that test is, what that value indicates. And again here the p-value is 0.07377, right? Means that again, I think both are same, 0.07 in SPSS also we have got the same value, okay? This value is again greater than 0.05, so we have to accept H naught, okay? We have to accept H naught, means there is no significant difference in the production values before and after training, right? That is how we should interpret the result. All right. Shall we go on or shall we stop? I think 11:30 is already there. So, and you might have another session. All right. So one way ANOVA is there, which is taken as the extension of t-test. Means what is the drawback of t-test is you can see maximum or you can check maximum two groups mean, equality of two groups only, their averages. But in real life we have several options, like suppose again profits of different companies you want to check whether it is same or not, like that. So several options we have. So in such cases we can use the ANOVA. Okay, again that is one way and two way ANOVAs are there. But next time if we get time we will discuss ANOVA on that lecture. Okay, so I think we should stop now. Yes. Lan madam, are you there?
Yes,
Shall we
yes,
stop?
ma'am. Yes, ma'am.
Okay. Shall I
Radhika,
stop?
Yes, ma'am.
propose the vote of thanks.
Okay. Thank you, Chaya ma'am. I would like to conclude this session by thanking ma'am. As ma'am give brief about testing of hypothesis with formulas and Excel demonstration. It's very helpful, ma'am. Thank you. I conclude that session is over. Thank you.
Thank
Next session time. Next session time.